questions here. There's two of them. And it's basically emptying water out of tanks. And the first one is going to be in pounds and feet, and the second one's going to be using metric. And there's a lot of information in this story. I've just drawn a picture of what's going on in 14, but essentially everything in this picture is what you're told. So you've got a cylindrical tank that's 10 feet tall, and I have it written down. It's radius, yeah. So let me find the question. Right, and this particular one is going to have a radius of, say, 5 feet. Right. And the tank's not full. The tank's only got 8 feet of water in it. So obviously the water starts at the bottom and goes to the top. And we're meant to take all that water out of the tank. But you don't knock a hole in the bottom, let it scoot out, because that won't require any work at all. What you're going to do is stick a tube in the top and essentially suck it out. So when you're doing this type of question, these water ones, first thing you're going to do is you're going to imagine that you take a random slice, I'll make it red, say here. And this random slice is going to be delta X thick. So you see the little slice there? And it's going to be taken by measuring it, let's say, whoops, wrong direction. By measuring it from the top. So from the top to that strip is going to be X. And this little like horizontal slice. So that's the first thing you do, because what you want to do is you want to find the weight of that slice. And that weight of that slice is essentially going to allow you to get force function. It's a little bit trickier than pulling things out of holes in the ground, but it's going to get us the force function. So how do I find the weight of that slice? Well, the first thing I'm going to do is find the volume of that slice. Would you agree that this is basically a baby cylinder, right? Tiny little coaster, and its formula is pi r squared h. In this case, it's pi. The radius is 5, so that's times 5 squared, and its height is delta x. So that's going to be 25 pi delta x, and that's the volume of that little strip. We're now going to get the weight. And water is a magic number. It's 62.5, and they tell you in the question, that's essentially what every cubic feet of water weighs. So if I've got this amount of cubic feet, I multiply it by 62.5. And I will get the weight of that strip. So here we go, 25 times 62.5, and I now have 1562.5 pi delta x's, and I now have the weight. And that guy that piece there is going to be our force function. Now it's a fixed number, and what's the delta x? Well, it's a little leftover guy. We can now get the work done. It's an integral from a to b of the force function, dx. And if you wonder what happened to the delta x, it became the dx. Now, in this case, it's going to be the integral of 1562.5 pi dx. And now we have to figure out, based on this, what the x's are. So you got this fella, and you got this fella. Okay. This is 10 feet, and from there to there is 2 feet. So won't the top of this thing be 2, right? And the bottom of this thing be 10. So we're pumping out water from position 2 to position 10. Do you see that? Right. Now, at this point here, it's a really, really ugly number, and you turn it into a decimal when you're finished. So even the pi doesn't survive. But can you imagine it's some ridiculously big, ugly number and you're finished? So the trick to doing these pumping water out is to choose a random slice of the object from the top of it to the slice. In this case, we'll call it X all the time. Find out what the volume is, multiply it by 62.5 if you're dealing with pounds and feet. And what that gives you is your force function. Okay, here's the second and final one of these. This one is written down in English, so it gives me a chance to show you the creating of the picture. Okay, it's an aquarium. So it's going to be 6 meters long. And it should have a width, 6 meters long, 1 meter wide, and 3 meters deep. There we go, not the very artistic. This particular one is in metric units. So that means we're going to have to use these numbers. When we did the water one, the magic number was 62.5. When you do metric, it's a combination of gravity and the mass. So it's going to be using these two numbers. Now, in this question, how much work is done in emptying half of it? Well, let's worry about that later. If you take a random slice, horizontal slice, looks something like this. This slice here. So let's find the volume of that slice. Well, it's length times breadth times height. It's going to be 6 times 1 times, just little delta x. So it's going to be 6 delta x's. Now we're going to get the weight. And that's going to be 6 delta x's times. Okay. You're just going to do this because I tell you. 1,000 kilograms per cubic meter. When you include gravity into the story, the magic number becomes 9,800. It's what you get when you multiply those two together, and it is what it is. So we put that whole package together. What we're going to get is a massively big number again. And this time it's going to be 58,800 delta x's, and that's the weight. And so our force function is just that number. Basically the weight without the delta x length. So we're going to get the work done. It's going to be the integral from a to b of the force function. It's going to be 58,800 dx. And we're left with just one not trivial problem. You want to empty half this tank of water. Right. Now it's 3 meters. So obviously you're going to empty 1.5 Agreed? 1.5. Now, if I'm measuring X from the top, which I am, what are the range of X's from where to where represents emptying that tank? Now, if I wanted to empty all the tank, it would be 0 to 3. That would be easy. But if you only want to empty half the tank, what are the two values of X that you're going to be looking at?
1.5 to 3.
Because when you empty half a tank, don't you empty the bottom? So 1.5 to 3. I don't like the way I said that. It wasn't very clear, and I know what's going on. Why am I doing 1.5 to 3 and not 0 to 1.5, which is really the other possible answer? Why is it that way around?
Is it because we're sort of looking at the problem from top to bottom?
Yes, essentially. It's orientation. Do you know I could have made X the other way around and it would have turned into 0 to 1.5? Agreed? Well, it's horrible. I'm glad they're over. I've done the last of my physics until we do hydrostatic pressure, which is absolutely horrendous when we get to do it, but we'll worry about that when it happens. We are now going to start our next section. And it's a lot easier than what we've just done. And it's 6.5, the average value of a function. Right, here we go. Imagine that you have your typical f of x. Starts at a, right, finishes at x equals b. Here is y equals f of x. If you think of this, the y values as being temperature, and a to b as being times, can you imagine this might be a curve that is the temperatures from noon till, from midnight to noon, right? Now, someone says to you, what is the average temperature? Normally to get averages, don't you add up everything and divide by how many? But you can't really do that. Well, you could do little snapshots, but that would only be an approximation. There is a very elegant formula for the average value of a function. And it involves integrals. Oh, come on, is that not elegant? The average value of a function is basically just the area under the curve divided by the distance from start to finish. That's what 1 over b minus a is, right? B minus a is that distance, right? So you're dividing it. I wouldn't write it this way, but can you imagine I did this guy over b minus a? Wouldn't that look a little bit like an average? So all you need to do is integrate something from start to finish, and make sure that you multiply by this fella, and you're done. So some notation. No one likes to write lots of English and mathematics. So we write, it sounds like I'm about to say favorite or something, FAVE, which is just the same thing as average. You will also see it in other textbooks looking like that. Anybody, any idea why that notation might make sense? Although that's going to be the one that we're using from this textbook. Why does that funny little bar hat on the top of an F make sense if you're talking about averages?
Doesn't that normally mean continuous or something?
No, not this one. No, I wonder where that's come. Have you ever seen that symbol? In fact, if you do statistics, which I'm teaching, that symbol means the mean of the data X. So that just means the mean of the function, right? The mean is another word for average, right? The mean of the function. Average of the function. That's something we don't need. That's it. 90% of what you're going to do is going to be finding averages, which means we get practice at finding integrals again. And so you got to have your thinking cap on. Can you just getting some questions set up here? So you're going to be using the power rule, and you're going to use, what else are you going to use? Oh, U-subs. Okay. So here is a random example. They give you a function. They'll tell you a start and finish value. And you're going to find the average. Right. And that's the notation they like. So it's going to be 1 over b minus a, the integral from a to b of our function. And that guy's a, and that guy's b. So what do I get? I get 1 over 2 take away -1. The integral from -1 to 2 of this fella. Would you agree that is not the worst looking integral in the world? We've done tons of these. So I'll be careful to take away negatives and add. So it's going to be power rule, evaluated at -1, evaluated at 2. And what we have here is 2 cubed plus 2 lots of 2 squared, take away 2. And that's going to subtract 1 cubed, 2 lots of 1 squared, -1. That's 8, that's 8, that's 16, that gives you 14. That's 1, that's take away 1, that's a whole load of zeros. And so the final answer is 14/3. So we've basically done the vast majority of average value of function questions. So what's going to be different? Can you imagine that these are going to be a little bit uglier to integrate, and that maybe these numbers are a little bit different, you know, something a little bit messier, but nothing much can be done except maybe make the integral a little bit harder to do. So let me find an integral that's harder to do. I would like to know the average value of this function. And the function is e to the 1 over z over z squared, and it's from 2 to 6. So the average value there's its formula. Okay, this is the problem. I need to integrate this guy. Definitely not a power rule. Someone said it should be 2 instead of 0. Is that because I can't count? Yes, it is. That's 2. Oh, which makes that 12 out of 13 makes it 4. Much nicer answer. Okay, back to this one. How are you going to integrate this guy? That's got you thinking. How are you going to integrate e to the 1 over z divided by z squared? I mean, we only really have 2 techniques, don't we? We have, power rule with all the other versions that you memorize, and substitution, right? That's the only 2 guys in town. Would you agree this one would have to be a substitution because it definitely doesn't look like the other stuff? So we have to pick a U sub. There are some candidates, but only one actually works. So who do you think we're going to use as our U sub?
One over z.
Okay, almost 1 over z. Right. Okay, why that? Well, don't we have a rule, e to the ugly guy? The ugly guy is your U sub. Would you agree e to the 1 over z qualifies? The other alternate might be in a different world, z squared, for instance, but it doesn't work this time. Now, this one here is going to cause its own little issues because I have to differentiate it. So I'm going to rewrite it as z to the power of negative 1. Then I'm going to differentiate it with respect to z, which is negative z to negative 2. And then to make my algebra a little bit easier to deal with, I'm going to write it like that. Then I can do my crossover. And what's that going to look like? It's going to look like z squared du is going to be negative dz. And then to isolate the dz, we get that. There's the working for my U sub. Now, I'll show you a little trick here. Obviously, it's not much of a trick, but something. You remove the limits of integration. And what you got here is a z squared and e to the u times the negative z squared du. And you've got that guy. So far, so good. Now, I haven't shown you my little trick yet. You get this guy. Me personally, I always return back to the original z values. So this turns into e to the 1 over z, right? And if I do that, I will get the correct answer. But you can, if you choose, and this is a little trick, you can choose to keep this guy. But if you're going to do that, the limits of integration have to change as well. So they're not 2 to 6. That's what z goes from. Z goes from 2 to z equals 6. In this fella, if you're going to use the u variable, the limits of integration come from here. So for instance, when z is 2, won't u be 1 over z? And when z is 6, won't u be 1 over 6? Do you see that you can use those new limits of integration? Me personally, I do not like to do that. But if you calculated this thing using these u values, you will get the right answer. What I try to do, and I think maybe it just works for my brain, is I always like to return back to the z's. And that way I can use the original start and finish values. So if you feel like that trick is worth it. You can certainly do it. I wouldn't do it unless you've done it a few times and you don't screw it up. I prefer always to do the questions to the end. Second reason I like to do it to the end, do you know those questions where you do a plus C at the end? Those have to be returned back to the original variable. If you start using this shortcut, sometimes what happens is that when you have an integral that just has a, an indefinite integral with a plus C, you leave it here and stick a plus C in, and you lose some points because it's not perfect. So in this case here, what do I get? 1/4, I get negative e to the 1/6. Take away is add e to the 1/2. And yeah, it's ugly, but it's the answer. Any questions about average value of function? Are we okay so far? One nice power rule, one rather ugly use up. Last chance, any questions? Okay. Well, about 3/4 of what you're going to do is pretty much those types of questions. So let's find something else. I wasn't going to do this one, but I just saw it. Something came to my mind. We're going to do the average value of this function from 0 to 3. So it's going to be the integral from 0 to 3. That guy. I think there comes a point in your Calc 2 career that you really need to know a lot of integrals by heart. You shouldn't have to go and look at, the big list of standard integrals and figure out what it is. So hopefully somebody can tell me, what's the antiderivative of that fella?
Or inverse tangent.
And thank you for saying inverse tangent. And I forgot to do my B minus A guy. So there he goes. So looks like if I bring out the 4, you get 4/3. Inverse tangent of 3, take away inverse tangent of 0. Inverse tangent of 0 is 0. And then you might think, what the heck is going to happen here? Well, let me tell you what's not going to happen. You're not going to get a calculator value for it and write down 1.2345 or whatever. We are interested in exact values, which means that you've got that guy. That's fine. Like 7 pi is fine. You don't turn 7 pi into a decimal. 4/3 inverse tan of 3 is an acceptable answer. Now, I've got a nasty feeling that WebAssign doesn't like you to write inverse tans. It probably thinks it means, I don't know, -1 powers.
It did work. I just tried it.
With the inverse thing?
Yeah.
Oh, thank goodness. I don't even want to say that term. Okay, that's good. Right, for the next couple of questions, I'm not going to actually do the question directly. We're just going to look at some questions from the homework. And you're going to tell me what technique you will use for integration. So we don't need to get into, right, I think I hit the wrong button. I think I did. Let me try that again. No. Right, you lot should be looking at 6.5 average value functions. I see a nod somewhere. Yeah, we're watching it. Okay. So did guy like that, power rule? Okay, what are you going to do in question 2 to integrate the square root of x? So this is really just practice at finding integrals. Tell me how to integrate the square root of x.
Power rule of x to the 1/2.
Agreed. Would you agree that one's just pure memory? 2 sine x.
Yep.
U sub, we already did that guy. Inverse tan, we already did that guy. Okay, question 6. How are you going to do that guy?
I think so.
U sub.
Right, who's the U sub going to be?
X cubed plus 5.
Agreed. Not the entire bottom, but just the x cubed plus 5, right?
Yeah.
Agreed. What's the U sub in 8 going to be?
ln of
Actually,
x
you
or
can't
ln
call
of
it a
u.
U sub. We'll have to call it a W sub, I guess, right? What's the W sub in 8 going to be?
ln of u.
Correct. How did you, what part of your brain told you that one? Because it is the right one.
When you take the u sub, you're taking the derivative of whatever you're ripping out, and you want that to ideally meet something that's there. The derivative of ln of u is 1 over u.
Correct. Okay. How would you deal with integrating 9?
This power rule, right?
Yeah, with t to negative 2. How would you deal with 10?
It would also be
Uh,
the power rule, right?
Yeah, if you did a u sub of x plus 2, it would be, yes. But you'd have to say u equals x plus 2. Actually, in this particular case, it would work because the derivative of x plus 2 is 1. So you would have got 1/4 x plus 2 to the 4. So you're correct, Maggie, but technically speaking, there's a little u sub that doesn't much do anything, but it is there. Oh, good one. I know how to do that guy, so I won't even worry about that. What's that guy going to need? How are you going to do that guy?
That's a trig identity.
Well, it is a trig identity, but if you want to integrate it, you might not need to use a trig identity this time.
You could also u sub, couldn't you?
Yeah, wouldn't it be just easier to do a u sub u equals 2x? You could do an identity if you wanted to. You could turn it into 18 sine x cosine x and do a different kind of u sub, and you'd end up with the same answer. What would the u sub in 13 be?
Pi t over 12.
Now, can you imagine you're just going to have to deal with some really ugly looking fractions? And what would the u sub in 14 be?
X plus 9.
Right. Are we getting more comfortable with these darn things? That's baby stuff yet. Okay. So time for me to go back and maybe pick one more of these and then show you the other thing. Oh, that's a good one. What u sub would you use in question 7?
Cosine to the power of 4x.
The whole thing or just the cosine?
Just cosine.
Just the cosine, sorry.
Just the cosine, right? Are we good? So we're basically 90% of what we're doing right now, isn't it just integrating things? You know, tagging on a 1/2 or something. So for the last one of this kind, I'll pick that one because it's in front of me. And so you'll see what I'm writing right now. And then we'll show you the last part of that section. Right now, we're only focusing on finding the average value. So it's going to be 1 over b minus a, the integral from a to b of whatever the function is dx. In question 7, it's from 0 to pi. So it's going to be then, 1 over pi, take away nothing. The integral from 0 to pi, and then it's 2 cosine 4s sine x's dx. And hopefully we all recognize that that was a u sub. We've already spoken about that. and the u sub is just the cosine of x. In fact, if you ever see combinations of powers and sines and cosines, like we have here, the u sub is either sine x or cosine x, right? One does, a better job than the other typically. Now, if you differentiate this guy with respect to x, you get negative sine x. You then do the crossover. And then you isolate the dx. We're all happy with those lines? Pretty standard u sub. Then we'll go over here and we'll do 1 over pi. And I'll remove the limits of integration because I'm going to switch over my variable. It's going to be 2 u to the 4 sine x's times negative 1 over sine x du. The signs cancel, there's a negative left over, so it's negative 2 u to the 4 du. It's a power rule, negative 2/5 u to the 5, and return back to the original x's. We're going to evaluate it at 0 and at pi. So it's going to be negative 2/5 the cosine of pi to the power of 5, take away negative 2/5 the cosine of 0 to the power of 5. Okay. Cosine of pi. What number is the cosine of pi?
-1.
Okay, so negative 1 to the 5th is still negative 1. Negative 1 times this guy, you get 2/5. Isn't the cosine of 0 1? So 1 to the power of 5 is still 1. Take away negative 2/5, you end up adding 2/5. And the whole answer becomes 4/5, 1 over pi. So 4 over 5 pi. Are you happy with that process? Right. If you know how you integrate, you know how to find average values. Agreed? I mean, isn't it just sticking in an extra funny little 1 over b minus a to your question? Any questions apart from that? Because we're now going to move on to the last piece of the puzzle. And it's called the mean value theorem. And it's to do, not surprisingly, with the mean value of a function, or the average value of a function. So I'll
Sounds
show you.
far more complicated than it is.
It is not complicated at all, I guess. Sometimes, I know. You know, like doctors have Latin names for, I'll make up some, so I don't know Latin anyway, but your tibia favia is fractured. And it sounds really impressive. And all that's happened is that you broke your little finger. You know, it's that kind of grandiose name to make something sound a lot more important. Scientists have been known to do that. So the mean value theorem might fall into this category. Right, I want you to imagine that we've got our standard function as we had at the start of the day, and it's going to begin at A, right? And it's going to begin at B. And we found the average value. Right? I'm just putting its formula, but we found that guy. It wouldn't surprise you that this number is somewhere between f of A and f of B. Would you agree that it would be reasonable to assume that the average value of a function is somewhere between its smallest and biggest value? Would you agree? And that's what the mean value theorem says. It says, can we pretend that this is where the average value is? And what it says is, there is at least one value of x in the interval a to b that has the property that f of x is equal to the average value. In fact, in this case, there's not one. Would you agree in this particular case, wasn't there 3 places that had the same value as the average value? We typically call these guys C. I know there's 3 of them, but we would say C is 2, C is 4, and C is 1.9, right? We would call them all C. So far, so good? So the mean value theorem just says that you're guaranteed to find at least one point on your function that has the same value as its average. And there are some conditions. The function that you're talking about, f of x, has to be well behaved. And well behaved in mathematical terms essentially means, don't you want a nice curly curve? You don't want any vertical asymptotes, any weird stuff going on, right? You just want a curve, you know, like curvy curve, nothing going on, nothing to see here. That's what a well-behaved function looks like. So as long as it's well-behaved, this property is true. So the types of questions that you're going to get are, here is a function, there's A, there's B. Find the average value, check, done that before. And then go hunting for the C's. Find the x coordinate of points that have the same value as the average, right? And we have time for just one of those. So I'm going to pick a nice easy one, some we can do quickly. So suppose we have a function f of x and it's x squared. Oh, let's make it even easier. 2x squared plus 1. And it's going to be in the interval 0 to 2. And it's going to be find the average value. And then we're going to basically find the C's, right? So let's get the average value first. Well, it's 1 over 2 take away 0. The integral from 0 to 2 of that guy. That's a half. Well, we can actually do that. What's that? X cubed plus x from x equals 0 to x equals 2. And that's that 2 cubed plus 2. Take away a whole load of zeros. Half a 10. Oh, and the answer is 5. So if you imagine me doing a little sketch of what 2x squared plus 1 would look like, in branching it looks something like that. If you're only interested in 0 to 2, I guess it's from here to here, right? We're only interested from 0 to 2. Then at some point 5, isn't there guaranteed to be some guy here, right? So let's go hunting for C. We know that the function is 2x squared plus 1. There are going to be 2 versions of finding this missing C. One version is going to be that you find the exact value. And the other version is that you're just going to get your calculator to find it, Desmos probably, right? And get the answer to, 4 decimal places. This particular guy has a value of 5. Can you see then? We get to there. So in this particular question, would you agree that we can get the answer exactly? We don't need to do a decimal version of it. Now, technically speaking, isn't x plus or minus square root of 2? But in this question, that's the only correct answer. Why is negative the square root of 2 not counted as a possible C value?
Not
Because it's
between
from
two.
0 to 2.
It's not between 0 and 2, right? So if you get 3 answers, because you might get 3 answers, let's say you're doing decimals, right? And decimals tells you there's 3 places where this happens. You only write down the ones that are in this range, A to B. If it's bigger or smaller than that, they don't count, right? C essentially is the value of this fella is the same as the value of the average, right? That's what you're telling. What would the analogy be? Can you imagine you recorded the temperature in a full day, right? From midnight to midnight, right? An entire day. And the average temperature ended up being 50 degrees Fahrenheit. Would it seem reasonable there'd be at least one time in the day where the temperature was 50, right? If the average was 50, shouldn't there be at least one time in the day, right, where it's 50? Now, there could be 2, couldn't it? It reach 50 and then it get warmer, and then later on in the evening it hit 50 and then it get colder. So it could be 2 places or even 3, right, where it reached 50. So what the average value of the function is saying is that if you've got a nice, well-behaved function, there's at least one place on that function that's going to have the same value as its average. If whoever got this hadn't got it, do you think you could have made that same assumption yourself if you'd thought about it? Right. I know how to get the average value. I wonder if there's a place on the curve that has that value. So if you'd got in early, you could have got that and named it. Perfect timing. Last game for attendance, and bye-bye. And I'll hang about for anybody who has questions. We learned some cool stuff today. Not so happy about the water stuff, but this stuff I like.
The water stuff was not fun.
Well, not for me, but for engineers, they love that kind of stuff, don't you? No, I'm putting words in their mouth. I'm assuming that they like that kind of stuff. But I'm kind of glad it's over with. But that's me. I don't know. I don't mind the chains with the water leaking out and that. They're kind of puzzly. I don't mind that one. Right.
I have a question.
Yes.
I haven't gotten my first exam test scores back
You
yet.
need to shoot me, Harrison, your email that you know works, and I will send it to you.
Okay, thank you.
So just say something like, "Can I get my what is it? Week 3 report,
Sounds good.
week 4 report?" Is actually not a problem. The solutions are online, so you can also, once you get it, you can check your answers against mine. Any other questions?
I actually did have a question about the
Okay.
mean value theorem problem.
Uh-huh.
that we-
Okay. Yeah.
So when you integrated it, I'm confused what happened to the 2.
1 to the 2. Okay, let me switch it back and see if we can figure out what happened to the 2. Okay. So this is the guy, right? This is the question you're talking about. This one?
Yes.
Okay, so are we talking about this 2 here or this 2 up here?
No, when you got x cubed, wouldn't there be a 2/3?
Ah, but when you add 1 to the power, oh, shooting space. I screwed up there, didn't I? Darn it. Okay, let's cheat. Let's make the question 3. There. Oh, that's not going to work because that's going to have to be 3 now. Okay, that makes that 3. That makes that 3. That makes this 4/3. That makes this plus or minus 4/3. That makes that 4/3. Which makes that 4/3.